Hi everyone, welcome to my YouTube channel, and today we are going to study Z transform. So first we have gone through the concept called Laplace transform, and Z transforms are closely related, where the concept of Laplace and Z transform are slightly varying in terms of discrete and continuous system. Laplace transforms are used in continuous system. As a formula you will be able to see that you have an integral over the limits, so it is a continuous system, whereas Z transform is for the discrete analysis. So the role of both Laplace and Z transform is transforming one function to another form, but the Laplace transform uses the continuous system and Z transform uses the discrete form. That is the only difference between the Laplace and Z transform. Let us go for the definition of Laplace Z transform. So here, as I told you, the system will be a discrete. So the definition goes like this. If the function un, this is what we denote un, is defined for discrete, we specific because Z transform is for discrete system, discrete values. Say the values of n ranges from 0, 1 to etc. and un becomes 0, u suffix n is equal to 0 for n less than 0. Then Z transform is defined to be Z indicates as a Z transform, un is the discrete function and that is equal to u of z. After the transformation, z is transformed to u, that is defined as, it's a discrete, so summation n is equal to 0 to infinity un into z power minus n, whenever this infinite series converges. Okay. Similarly, we can define it for inverse Z transform, where you just have to shift this Z onto other side. So inverse Z transform is inverse Z transform is shift Z to another side. So we have Z inverse of u of z, that is equal to un of z. So it is more or less similar to the Laplace transform, where here we are using the discrete system and Laplace we will be using the continuous domain. That is the only difference between the Laplace and Z transforms. So here comes the standard Z transforms. It is similar to what we are using in Laplace transform. So these transformation will help us to solve problems. So first basic transformation is Z transform of a to the power n, where a is a constant, n represents a discrete system. Whenever we have Z transform constant to the power n, then we can directly write its transformation as z by z minus a. The value of a, if it is 1, so accordingly you can replace z by z minus 1, and a is 2, z by z minus 2, and so on. Similarly, Z transform of n power k, that means n is the number, okay, n power k, n is our function, actually n is our function. So what we have, minus z d by dz represents the derivative of z transform of n power k minus 1, where k is constant, n is nothing but the function. Here the function is un. I have already informed. The function is defined as un, and let k be any positive integer. So these transformations we have to keep in mind because these are used in solving problems. As I already told, if suppose for the first case, if we have a as 1, you can just replace z by z minus 1, and if a is equal to 2, replace z by z minus 2, and so on. So this is a first basic standard formula in Z transform. So let us have some example. So Z transform of 1. So you need to compare which formula will be feasible. Second one is n power k, that is variable power constant. First one is constant power variable. So instead of a we have z, so it is z minus 1. That's it. That means the value of a is equal to 1 in this case. Similarly, we can do it for the other terms also. Put z as z of 2. So that means the value of a is equal to 2. So what happens to z transform of a power n? That can be written as z by z minus 2. Remember, this is constant power variable, and this is just ulta, variable power constant. Whenever you have variable, n is the variable. When variable power constant you have, please remember it goes for differentiation. If it is constant power variable, then it goes for integration. So this two you have to keep in mind. Considering to the second standard formula, so let me take an example. Z transform of n. Okay. Here you can see the power k is 1, so k value is 1, and this is variable power constant. So in this case we are supposed to use the second result, that is Z transform of n power k is minus z derivative with respect to Z transform of n power k minus 1. Since k is 1, this will be rewritten as Z transform of n, that is equal to minus z d by dz of Z transform of n to the power k minus 1. K is 1, so 1 minus 1, so it is n power 0, that is equal to Z transform of 1. So minus z d by dz of Z transform of 1. Already we know what is Z transform 1. We need to substitute here. So it's minus z d by dz of differentiated z by z minus 1 by applying quotient rule, because z is existing in both numerator and denominator. So it's minus z denominator square, denominator into differentiation of z with respect to z is 1. Z into differentiation of z minus 1 is again z. So we are left out with minus z, z minus 1 minus z. So they get cancelled each other, divided by z minus 1 the whole square. So ultimately z transform of n is nothing but z by z minus 1 the whole square. Similarly, you need to remember the results, what happened when z transform of n to the power 2, n power 3 and n power 4. So z transform of n square, that means the value of k is equal to 2. Substitute in the formula, we will get z square plus z by z minus 1 the whole cube. Similarly, when k is equal to 3, z transform of n cube, that is equal to z cube plus 4z square plus z by z minus 1 the whole power 4. If we remember all the results of this, It will be very useful when we are solving problems. If you have forgotten the formula, no issues. Remember the standard formula and then just put the value of k. You will be able to get the Z transform of n power k directly. Next comes Z transform of linearity property. Linearity property we have studied in the basic derivative, in any other forms also we have studied, where the functions are applied only to the variables, not the constant. So here a, b, c are turned out to be a constant. So when I apply the linearity property, it becomes a z transform of un plus b z transform of un minus c z transform of un. So it's, we'll change the function u, v and w. So here u, v and w. So we can take the transformation inside and keep the constant outside. How we used to do it for differentiation, the same steps. Next comes the rule called damping rule. So we know z transform of un is nothing but u of z. Some textbook refers u bar of z or capital U of z. So it means the same. So when we have a z transform of un is equal to u of z, then according to damping rule, we have z transform of a power minus n into un. See, as I told you, our function is u and n. A is turned out to be a constant. So whenever you have a constant power negative function, then you can use the damping rule. That is, your answer can be directly written u of az. That's it. Some textbook use a as k, so based on your reference textbook you can change the variable. But only thing is, when you apply a damping rule for a power minus n, then your solution will be u of az. That means same what we did for Laplace transform, take the transformation for the given function, and whatever the function you have got, replace that function with az. Similarly, we have z transform of a to the power n. So remember, here we have negative for the first one and here we have positive. When we do so, here your solution will be u of z by a. Whenever a power minus n un, your solution will be az. A power positive n un, your solution will be z by a. Nothing but take the transformation to the function. The obtained answer can be replaced z by z minus a. Same here, transform the function. Obtained answer will be replaced by az. So coming to some standard result based on damping rule. So first you have to list what is a known result. Z transform of n power k. So that is minus z d by dz of z into transformation, that is n k minus 1. So this is what we have. Here you can see we have n power 1 and we have a to the power positive n. So you can just check the damping rule. So whenever you have positive n, you are supposed to replace the obtained result z by z minus a. So you need to remember we have applied damping rule to the second condition here. So your first step is take the transformation to the function. So first let us rewrite this as z transform of a power n into n. So we know the function is n. So what do you have to do first? Z transform of n. Whatever the answer you get, you are supposed to replace the solution by. Since it is a positive power n, so solution will be replaced by z by a. That's all. So that is the only thing you need to learn here. Solution will be replaced by z by a. So let us proceed here. Z transform of n. We have already proved z transform of n is, after differentiation we got z by z minus 1 the whole square. This we have done, right? Similarly, we can substitute it here. Okay, this case a value is 1, here the a value is, okay. So let me apply the transformation here. So it is z by z minus 1 the whole square. Whatever the answer I get, I am supposed to replace it by z by a. So you have to just replace z by z minus z by a. So it is z by a divided by z by a minus 1 the whole square. Take the LCM. So it is z by a, it is z minus a by a square. So we have z a square by a into z minus a the whole square. 1 a and a cancels out because of numerator and denominator. So z transform of a to the power n into n is obtained as z a by z minus a the whole square. This transformations are all very important, and we have got this transformation by damping rule. That means when you have one function, you can directly go for applying the formula which we have learnt here. You can apply this formula when we have only n or n square, n cube or so on. But along with n, if suppose you have some constant term, then you can approach these formulas. So it is a product of constant power variable into function. Similarly, we can do it for z transform of n square into a power n. So first, what is our step? Rearrange it. Z transform of a power n into n square. So our function is n square. Take the transformation for n square. How do we get the result? The value of k is 2. Please remember the formula. Z transform of n power k is minus z d by dz of z transform of n to the power k minus 1, right? Here the value of k is 2. First you need to find this transformation. Now see the power of a. It is positive. So whatever z you get, replace z by a according to damping rule, because you have product of function. So I am going to replace k by 2. So I get minus z d by dz of z into n power 2 minus 1. So it is minus z d by dz of z transform of n. So from the previous result, we know what is z transform of n. Z transform of n is nothing but z by z minus 1 the whole square. Please substitute that here. So it's minus z d by dz of z by z minus 1 the whole square. Now you are supposed to differentiate this with respect to z once. So as we know, quotient rule, denominator square. So it is 4. Denominator into differentiation of z with respect to z is 1. Z into differentiation of denominator. So it is 2 z minus 1 into 1. That's it. So on proper simplifications, it's minus z. You can see z minus 1 is common. So I am taking z minus 1 out. So one power is out. So it is z minus 1. This is already out. So we are left out with minus 2z divided by z minus 1 power 4. 1 of numerator, 1 of denominator. We are left out with just 3 in the denominator. So right now we have just calculated z transform of n square. But whatever the answer we get, we are supposed to apply damping rule as per the question, right? So it's minus z into z minus 2z is minus z minus 1 divided by z minus 1 the whole cube. So minus of minus plus, so it is z square plus z by z minus 1 the whole cube. This is just a simplification of z transform of n square, that we have got z square plus z by z minus 1 the whole cube. But our question is not z square, our question is n square into a power n, right? So whatever the answer we have obtained, you are supposed to replace it by the damping rule. Since it is positive power, I am going to replace Z by A. If it is negative power, replace Z by AZ. That's all, as simple as such. So you just have to substitute in place of Z. So it is Z square by A square plus Z by A divided by Z by A minus 1 the whole cube. Careful simplifications is required. Here the LCM is A square. So it is Z square plus AZ by A square, and here we have Z minus A the whole cube by A cube. You have to simplify it further. So it is Z square by AZ by A square into Z minus A the whole cube, and denominator A cube goes to numerator. So we are left out with Z transform of n square into A power n is A Z square plus A square Z divided by Z minus A the whole cube. So this is how you have to remember the formula, and all these formulas are highly important when we are solving problems. Similarly, you can do it for, you can try it out for Z transform of n cube A power n. Similarly, you can try it for negative power also. So I'll just write it for n cube A power n. First, you should know what is Z transform of n cube. Whatever the answer you get, supposed to replace it by Z by A. So Z transform of n cube, if you want you can calculate, put k is equal to 3. So we get Z cube plus 4Z square plus Z by Z minus 1 the whole power 4. Shift Z to Z by A. The easiest way of remembering is the maximum power of Z will have minimum power of A. So it is A Z cube plus 4A square Z square, and the least power of Z will have maximum power of A, that is Z into A cube. That's all. And the value of 1 will be replaced by the value of A. That's it. This is the easiest way of remembering the formulas. Once you know n square n cube, you can just use the concept of maximum power of Z as the least power of A. So coming to the next important concept, it is asked in most of the university papers, and the easiest way of getting this Z transform of cos and theta and sin and theta. So we will apply the damping rule, that's the most easiest part. So first we should know the basic results, that is Z transform of 1, that is Z by Z minus 1, right? And we know e power I theta. The expansion of e power I theta is cos theta plus I sin theta. And similarly, we know e power minus I theta will be cos theta minus I sin theta. Instead of using positive I theta, I am going to use negative I theta. Why? Because it is easy to apply damping rule, because according to damping rule, Z transform of A power minus n into un will be just u of az. That means I just have to replace z by az. There is no numerator and denominator term. And you can also try with positive n, where you need to replace z by a by z. That's only difference. And this is the easiest way of solving and getting the result. Before that, you should know z transform of 1 and z e to the power minus I theta is cos theta minus I sin theta. So let us take the transformation, that is Z transform of. You can see the question, we need to have cos n theta and sin n theta. So instead of e power I theta or minus I theta, I take it as cos I n theta. Okay. So I just write Z transform of e power minus I n theta, because I need cos n theta and sin n theta. Instead of writing this, I can also represent it as e power minus I theta whole power n, because our function is n and e power minus I theta is turned out to be a constant. Instead of writing this, I can also represent it as e power minus I theta whole power n into 1, right? So you can take the transformation to the function, right? And whatever the answer you have obtained, you can apply the damping rule and replace z by az. You can use this concept because you have minus here, right? So here you can take a as e power I theta, right? So that this will be written in the form z of e power I theta the whole power n into 1. So according to this formula, damping rule, you can just have to find transformation of 1, which we already know it is z by z minus 1. And wherever z is there, you are supposed to replace it by e power I theta. That's it, right? So by applying damping rule, okay, I just write the damping rule also. That is z transform of a to the power minus n into un. So you need to apply the transformation to the function that gives z transform of un, right? Wherever you have got z, replace it by az. That's it. So here you can also compare the value of a is e power I theta, not e power minus I theta. So I'm just going back to the question. So z transform of e power, okay, I'll just write I theta power minus n, okay, into 1. So I'm just supposed to take transformation to 1. So it is z by z minus 1, right? Z by z minus 1. And I am supposed to replace z by e power I theta according to damping rule. So I am just left out with z into z. So z e power I theta by z e power I theta minus 1. I hope this is understood according to damping rule. So according to damping rule, I just have to substitute. So you can take off this e power I theta common. So we have e power I theta. When I take it out, it is z. And similarly, e power I theta. When I take it out, we have z minus e power minus I theta. So these two get cancelled each other. So we have z by z minus e power minus I theta. For further simplification, you can take the complex conjugate. It is complex conjugate, that means I only, the negativity of I will become positive and positivity of I becomes negative. That is what we call complex conjugate. Okay. It is not just a conjugate, it is complex conjugate. So what happens? Z by z minus e power I theta into, you can see the difference. It is z minus, but instead of minus I theta, I am taking positive I theta. Similarly, I am taking it for denominator also. This is what we call complex conjugate. You just have to multiply it. And we know e power I theta. What is e power I theta? Cos theta plus I sin theta. You can use the result when you are multiplying. So we have z into, we started with e power I n theta, right? On expansion we have got this term, so it is z into z minus e power I theta. I am expanding it as cos theta plus I sin theta. Similarly, multiplying these two terms, so we get z into z square minus z e power I theta minus z e power minus I theta minus of minus plus e power minus I theta into e power positive I theta. We can multiply the z inside, so it is z square minus z cos theta plus I z sin theta in the numerator. So denominator is z square. You can see here there is a common minus z. When I take it out, it is e power I theta plus e power minus I theta. And this power bases are same. When I add the power, I get e power 0. So as we know, e power 0 is 1. And e power I theta plus e power minus I theta is nothing but 2 cos theta. Okay. So we have, I am grouping the real and imaginary now. So it is z square minus z cos theta. This is real part plus iz is the imaginary part whole divided by what is left out? Z square minus 2z cos theta, because e power I theta plus e power minus I theta by 2 is cos theta. Since pi 2 is not there, we can rewrite it as 2 cos theta. E power 0 is 1. So you need to segregate the real part and imaginary part. So e power I n theta, that is minus I n theta, is, I can take z common out here, so it is z into z minus cos theta by z square minus 2z cos theta plus 1. Similarly, I have I z sin theta by z square minus 2z cos theta plus 1. So we can take the real and imaginary part, right? So the real part is the first term and imaginary part will be the second term. So here we have just left one negative term because I have opened up the bracket, so it is minus iz, and similarly here also we have minus iz, right? So here we have minus. So we are going to expand the LHS, so it is cos n theta minus I sin n theta, that is equal to z minus cos theta by z square minus 2z cos theta plus 1 minus iz sin theta by z square minus 2z cos theta plus 1. If you equate the real part, you will get z transform of the function, and imaginary part will be the sine function. So z transform of cos n theta will be z into z minus cos theta by z square minus 2z cos theta plus 1. Similarly, when I take the imaginary part, so z transform of sin n theta will be z sin n theta divided by z square minus 2z cos theta plus 1. So if suppose along with cos and sine you have like a constant multiplied, right? So which we have done in damping rule, z transform of a power n cos n theta. Since it is positive n, you are supposed to replace z by a. As I already told you, you can just rewrite this as, okay, z into z minus a cos theta divided by z square minus 2z a cos theta plus a square. Cos will be replaced by a coefficient a and constant 1 will be replaced by a square. That is the only way you can easily remember. Similarly, z a power n sin n theta. Since we know sin n theta transformation, you can write this. Since it is positive power n, replace z by a. Okay. So you just have to remember the trigonometric functions will have the coefficients. Okay. So it is az sin n theta divided by z square minus 2 za cos theta, and that constant 1 will be replaced by a square. So this is the first part of part 1. We are going to end it here. So the next part 2 you can continue in the next lecture. I hope this concept is clear to everyone. Thank you for all support. Kindly share and subscribe to my channel.